This is part 2 of Chapter 8, Section 2, Experimental Probability. So looking at the number 4 here, it says, for the past 2 weeks, Jimmy has been counting the number of joggers in the park between 8 and 9 p.m. of each evening. In that time, there have been 40 or more joggers on 7 out of 14 days. Let's try to there's a lot of numbers in this question here. There's a lot of extra information. Let's go ahead and get rid of some of this. First of all, for the past 2 weeks. Okay, he's been doing that. We know that because he did 14 days. So let's get rid of all of this stuff right here. It doesn't matter who it was. Jimmy was counting the number of joggers in the park. It doesn't matter that he was counting them between 8 and 9. That doesn't matter. It doesn't matter that it was in the evening. This is what's important. In that time, there were 40 or more joggers on 7 out of 14 days. So we want to know what the probability is. It says, what is the experimental probability that there will be 40 or more joggers? So that's a success. So having 40 or more joggers on the 15th day, well, a success means that there were 40 or more. And so let's go ahead and circle this part right here. 40 or more represented a success. This was a good item. A number of times a certain event will end up happening is another way of representing that. Well, what we're going to end up doing is writing the probability for that. Well, the probability is how many times it occurred. So how many times did it occur that he had 40 or more? So we want the probability of 40 or more joggers. So how many successes occurred? 7. 7 days that happened. So 7 out of what? What was the total number? 14. What does that reduce down to? 1 over 2. So it's 1/2. So that's the probability that it's going to occur. It's 1/2 that there'll be 40 or more. So on the 15th day, well, it's half, 50-50 chance. So it could end up happening. So it's as likely as not. So our answer would be just 1/2. It's whatever number this is. Now, how about that there'll be fewer than 40 joggers? Typically, what we'd end up doing is we'd do 1 minus 1/2, because 1/2 represented with 40 or more, fewer would be the other amount that adds to make the 1. But in this case, since we don't have any other numbers except for just 1/2, the half of that is half of 1 is 1/2. So when I go ahead and come up with that common denominator, you'll see when I subtract, I get the same answer, 1/2. So 1/2 is the answer again. Well, in the next one, if Kathy hit the dartboard 9 out of 10, or 9 out of 15 times. Okay, let's write that down. Kathy hits it 9 out of 15. Okay, that is, and we'll say the probability of hits. Okay, hits the dartboard 9 out of 15 times. Now the next person, Toby. Toby hits the dartboard 14 out of 20 times. Who has the greater experimental probability of hitting the dartboard? Okay, we just want to see which fraction's bigger. That's all it is. So the best way, I think, to do is you got to come up with a common denominator. But what I'm going to end up doing is I'm going to change these fractions so that they do have a common denominator. And so I'm going to try getting rid of this 3 that's in here. I'm going to divide it by 3. Let's divide by 3. And when I do that, I'm left with 3 out of 5. Okay, I'm going to leave this one as 14/20ths because, look, I can make this 3/5. I can make that equal a 20 on the bottom. See, if I multiply it by 4 now, that gives me 12 out of 20. And look at this one is 14 out of 20. So now you see I have the same denominator. Now I can compare them. Who has the greater amount? It's Toby. Toby has the more chances of hitting it because he hits it more often. So I would say Toby was going to end up having the greater chance of hitting it the next time. Next one here, one works at a snack bar, and it says, of the first 25 hot dogs ordered one day, 19 were ordered with sauerkraut. Okay, so the probability of having sauerkraut on the hot dog was a success, was 19 ordered it. So 19 successes over 25 total. Well, what they want to know, if the snack bar expects to sell 150 hot dogs on any day, how would they expect to order? How many would they expect to order sauerkraut? Well, let's just come up with an equivalent fraction. And so let's do this. Let's set up a proportion, a line equals sign line problem. So we got 19 over 25 equals x over 150. See, 150 is a total. 25 is a total, so they go on the same side of the fraction. So from this point, we can go ahead and just cross multiply. Multiply the 19 times the 150. So that goes on one side, and then we're going to end up multiplying the 25 times the x. So it's 25x equals 19 times by 150. So go ahead and multiply that. 19 times by 150, just do 19 times 15 and add a 0, and you end up with 2,850. And this all equals 25x. And then all you have to do is divide by 25, and you'll have your answer. And so it does go in there evenly. If you think of how many quarters make $28.50, you'd have your answer. Let's see how many that is. It's 114 of them. So that's what we would say. About 114 are ordered with sauerkraut. So that's what our approximation would be using experimental probability. Well, those are types of problems you'll see on tonight's homework. Good luck.